Hello, and here are the answers to the case paper from spring 2004. I've got a horrible cold, so I do apologise if I have made any errors. Bonus points if you can spot them. Okay, so here's question number 1. It is a question on bearings. Part 1, you need to draw a sketch, fully labelled, of where A, B and C are. Don't forget to label 72 degrees there, 072, and also it's an isosceles triangle. To calculate BOC, you take away 72 from 180, divide it by 2, 108 over 2, which is 54 degrees. The bearing of C from A, so C from A, so we're looking at this angle here, this top angle. Remember, bearings you always measure from north and you go clockwise. So it's 180 minus this angle, which is 54, giving you 126. And finally, for the number of sides of a regular polygon, if you know the middle angle here is 072 degrees, then we work out how many of those can go into 360, which means you have 5 sides. Okay, here's question number 2. The mean of a set of numbers is 8, which means if you have 12 numbers, their all value is 8. 8 times 12 is 96. And if you add 3 numbers to that, you've now got 15 numbers, the mean is 10. So 15 times 10 is 150. Now I said n is the first consecutive number. Consecutive numbers means they go up 1 each time. So we've got 12 lots of 8, that's our original mean, plus n plus 1, that's the next consecutive number after n, plus n plus 2. And if I simplify that, I get 99 plus 3n. Therefore, 3n plus 99 is 150, take away 99, 3n is 51, so n must be 17. So the consecutive numbers are 17, 18 and 19. Question 3 is a question on probability. Always write that as a fraction, always check you can simplify. There are half in number of even numbers, so 50 out of 100, which is a half. Containing the digit 5, you've all got all those numbers that end in 5, but also all those that start with 5, but don't count 55 twice. Make sure you only count it once. So 9 of these so 10 of these and 9 of these, so it's 19 out of 100. So that's wrong, that should be 19 out of 100 for the answer. For the part 3, we're looking at multiples of 7 or 3 or both. So I did the multiples of 3, there are 33 multiples of 3. Likewise, there are 14 multiples of 7, 7 14s are 98. However, because we've done 3s and 7s, there are some which are multiples of both. And again, we don't want to double count these. So the multiples of both are 21, 42, 63 and 84. There are 4 of those. So we do 33 plus 14, that's the multiples of 3 and 7. We take away the ones of both, which leaves you with 43 over 100. Question 4 is on inequalities. And remember, whatever you do to one side, in this case, whatever you do to any side, you've got to do to all 3 sides of that equation. So for part 1, we took away 2 from each side, and then we divided by 5. Be careful about your signs. X can be 3, 4, 5 or 6, but not 7. 7 is not included. For this one, you can either minus the 1 first. I times by 100 first of all, and then I took away 100, which meant X could be any of these numbers here, minus 1 to 5, and including the 5 this time. This one's slightly trickier. If we take away the 2 for our first step, and then we divide by -1, because I'm dividing by -1, I've got to swap the inequality signs around, and then I divide by 3, so x can be -5, -4, and -3. Remember, in inequalities, if you divide by a negative, you have to flip that sign around. Okay, question 5. A lot of work to do for 6 marks here. I've written out the key bits of the question. Worked out for house number 1, 60% of 150, which gave you 90,000. And then for all the other houses, they're just 10% more. So they're £15,000 more. So you get 105, 120, and £135,000. So therefore, the total revenue is adding those up. You get £450,000. The percent profit is the total revenue taken by the building costs. And don't forget that's the buying cost and the building costs. As a fraction times 100. If you simplify, you'll then get a ninth of 100, or 100 over 9, which is 11 1/9%. Question 6 is on sequences, where Tn is the term of a sequence, and what you do is you substitute in for n. In this first one, n is 1, so you do 3 times 1 plus 9, which is 12. N equals 2, 3 times 2 plus 9, 15. So you're going up in 3 each time. In this next one, it's to the power of n. So to the power of 1 is 2, 3 times 2 is 6. To the power of 2 is squared, 3 times 2 squared, 3 times 4 is 12. Then 3 times 8, which is 24. And 3 times 16, which is 48. So you're doubling each time there. Part 2, you've got to look and see how you can use these first two to work out the next one. And I spotted that 18, 27, 42, 69 is the sum of these two here. So I worked out that the next one in this term is 24. The next one in this one, if we double again, is 96. So then I add them together and I got 120. For part B, it's a division. It's this one divided by this one, or as a fraction, this one over this one. They've been simplified where necessary. So for the next term, it's 96 again over 24, which simplifies to 2. So for Tn, it is 3 times 2 to the power of n divided by 3n plus 9. But you can simplify that again because there's a common factor of 3, and it becomes 2n over n plus 3. Okay, for question 7, you had to make it clear that the volume is the width times the depth times the height. Maybe explain why the width is 16 minus 2x. It's the total length. Take away an x from both sides. And then just say rearrange, and you get that the volume is that. The missing values for the table are here, are shown. So 12, 6, 144, 10, 4, 120, 8, 2 and 64. And then if you've downloaded the graph paper, you get something that looks a bit like this. So it's a nice curve. Don't forget to label your axes and your numbers on each side. So it's value of x in centimetres, volume in centimetres cubed, and then show your nice parabola. If the volume is 120, draw a line across to your graph and drop it down, and I reckon that was approximately 1.15 centimetres, give or take a little bit depending on how you've drawn your curve. Okay, question 8 was a bit of an interesting one. We worked out that the total gold in our 2 bits was 12 grams from the 12 karat gold and 42 grams from the 21 karat gold, but because you've got 48 grams in total, you double it to 42, which means I've got 54 grams of gold, pure gold. The total mass is 72 grams, so I've got to make that out of 24, so it's a third of 24, so 54 times a third is 18 grams. So Y would be 18 carats maybe rather than grams there. So there'll be 18 grams in every 24 grams of material. Now the amount of pure gold in the second bit would be 80 over 24 times 15, because there's obviously more than 24 grams, so you've got to work out how many lots of 24 there are, and then times that by the 15 carats, which means that 50 grams of pure gold. Now let G equal the amount of gold I'm going to add to this, so I need my fraction of pure gold over total amount to be the same as 18 over 24, because I want 18 karat gold. I simplified the 18 24ths to 3/4, and then I cross-multiplied, and I got 4 lots of 50 plus G, and I've got 3 lots of 80 plus G. Multiply the brackets, collect like terms, and you find you have to add 40 grams of gold, of pure gold, to make that into 18 karat gold. Question 9 is like a rearranging one. You're looking at all the different possibilities. You're also trying to spot the pattern there. For 4 letters, there are 3 combinations of non-adjacent letters. Part 2, there are 3, 2 and 1. We're starting with different letters, so that's giving you a big clue about the next bit of the question. So there's going to be 6 different combinations of non-adjacent letters. For the next bit, if I've got 6 letters, if I look back at this pattern, it's 1, 2, 3, and I'll have 4 lots for the next letter, as it were. So I'm going to add on 4, which gives me 10 pairs. The same thing for 7 letters. If I add on 4, the next time I add on 5 pairs for that one. Now these are triangle numbers. We've got 3, 6, 10, 16. And so if I've got 26 letters, I want the sum of all the numbers up to 25. So I plug it into that equation for triangle numbers that they gave us. 1/2 times 25 times 26. Bit of rearranging, and I get 325 pairs. Okay, here's question 10. We see we've got the circumference 480, so the time it takes is distance over speed, which is 120 seconds for Albert. Likewise for Bert, 60 seconds. So if you look for the lowest common multiple of 60 and 120, it's 120. So Bert does 2 laps, while Albert only has time to do 1, and then needs to go. Same for part B, 480 divided by 6, which gives you 80 seconds for Albert, 48 for Beatrice, and then the lowest common multiple of those 2 numbers is 240. Either using your times tables or look at the prime factors for those. Part 2, the distance is 240 metres, divided by speed is 5, so it takes them 48 seconds to get to Y. And then each lap would be 480 divided by speed 5, which is 96 seconds per lap, which means it's 3 times R48, 144 and 240. Don't worry about part B, it's far more difficult than anything you can expect coming up. Question 11 is on Pythagoras and circles. Just state that 1 unit is half the length of one side. For this one, you need to show that it's Pythagoras, so start off with Pythagoras, its formula, theorem, substitute in the numbers, and then show that it equals root 3. It's like when you're given the end of a story and you have to write the beginning of it. It's the same in maths. You're given the end, you have to go right back to the beginning and start from there. Area of AFO triangle is half the base times the height, and substitute in your numbers and you get that it's root 3. The area of AXO is half of that, which would be root 3 over 2. The hexagon is 6 lots of those bigger triangles, 6 lots of AFO. Substitute in and you get 6 root 3. Root 3 you can treat just like a variable, just leave it like that. It's like x or a or anything like that. So just say 6 root 3. Next bit, the radius of the circle is 2. So pi r squared, pi times 2 squared gives you 4 pi. And the next part, same thing, the radius is root 3. If you square root 3, you get 3. So the square root of n is squared is n. So when you square something in the square root, you lose the square root to do well. Then for the final part, tricky question, but you know the smaller circle's area is less than the hexagon, which again is less than the bigger circle. So that's the inequality. Area of a small circle is smaller than the area of the hexagon, which is smaller than the large circle. Plug in the numbers, cancel, simplify, rearrange, and you end up with the 2 root 3 is less than pi is less than 3 root 3 over 2. Add up your marks. It's a tough paper. It's out of 100. Give yourself a mark and I'll expect to see that back in when we come back after half term. Enjoy the rest of your break.